Okay, so my screen is visible.
Yeah.
So
Just
shall I start?
1 second. Mm, Hey, Rajiv.
Oh, hi.
Hi, Raji.
How are you? Hi.
It's Shailja.
Shailja, hi. Nice to meet you.
Okay. Same
So
here.
we can get started because this is getting recorded and it will be published. So,
Okay.
Shalja, like, why don't we? I think let me start at the broader picture, and then you can start with the introduction also. And we will take the question answers at the end. Uh, so, at a high level, again, like my name is Vijay, and leading vertical serve. We have done ton of work in the supply chain analytics side, doing supply chain analytics on Google Cloud, utilizing some of the pre-built artifacts what Google Cloud provides. The main idea is how do we bring all the supply chain data on Google Cloud. There is a concept called digital twin, which is a supply chain involves a lot of pillars: sourcing, manufacturing, like warehousing, delivery, and ultimately a customer buying the products and all, right, which Shelja will go through that. But the whole idea is how can we bring this data from various companies which they store in SAP or some other ERP systems to Google Cloud, leverage Google Cloud's cloud scale and some other tooling which is provided by Google Cloud. Like machine learning is the most important one, machine learning, artificial intelligence, and how companies can build modern supply chain analytics platform on Google Cloud, leveraging these artifacts. And so this session is all about supply chain analytics, and we will focus more around demand sensing, which is a modern way of doing demand predictions for supply chain side. And we know like a lot of companies are facing some of the supply chain related problems and all recently. By leveraging this centralized platform, they can get more insight and see the bottlenecks and improve and bring efficiencies to this whole thing. So I'll pass it on to Shelja. Shelja, why don't you introduce yourself and let's get started?
Thanks, Vijay. I'm Shailja. I have around 12 plus years of experience in SAP area, SAP ABAP, and I mostly work with sales and distribution module with having understanding of other modules as well. And currently, I'm working as a business in a business analytics role and helping the companies to in the supply chain area. Yeah, this is about me, and today I will be focusing on how we can leverage the supply chain data and uh, integrate into the Google Cloud, and how we can leverage the Google Cloud services as well. So let's start with the introduction. So, as we all know, supply chain is a combination of few activities like procuring the material, then transforming them into the final product, and then delivering it to the customer. So, it is a group of processes of planning, sourcing, making, and then delivering. And we have several stages in the supply chain like procurement of the material, manufacturing, then the storage and the inventory and distribution and the retail, and then the selling to the customers. There are few challenges in the supply chain as well, like having a wrong material at the supplier end, having supplier shortages as well. At a distributor end, we can have high inventory, and also lack of efficient logistics can happen. Then at the customer end, we can have ineffective promotions and poorly organized inventory as well. So to avoid these few of the challenges, we plug in analytics in supply chain. So let's see what can be the benefits of supply chain analytics. So we can have improved margins and customer satisfactions. How, like with having a smarter inventory and planning decisions and more efficient shipping schedules, we can have we can improve the margins and the cost uh, of our supply chain. And then we can better understand the risk as well. How, like by spotting the patterns and the trends in prior, we can better understand its risk, and also can increase the accuracy in the planning. Then, by analyzing the customer data, we can anticipate our future demand as well, and we can if the profit increases, we can minimize the product. Like if the profit decreases, we can minimize the product making as well. So, this way, we can achieve the lean supply chain, and we can prepare for the future as well. So let us understand about digital twin. So digital twin is a digital representation of a real world physical product. It can be a system or a process that serves as a digital counterpart for other practical purposes, such as integration, testing, any maintenance, etc. So similarly, Google Cloud is providing ready to deploy connectors or transformation pipelines based on the Google data to bring the ERP systems like SAP into a BigQuery data platform. So, and also we are provided AI ML functionalities on the supply chain data, and we are going to talk more about that in our uh,
So I'll add few
further
lines.
slides.
I'll add few lines here, Shalja. So think of digital twin as a, so right now, as you see the diagram, right? You've seen that there is a manufacturer there, there's a distributor, wholesaler storing the inventory and all. So currently what happens is in the companies, each and every system has, they store their data in their own databases. If there is any disruption on logistics side, some things are captured in documents uploaded on a nightly basis, then get pushed down to some of these tables. And the companies have operational analytics like maybe happening once a week or so. So that whole physical implementation of the supply chain is very cumbersome actually. And the decision making, any disruption can cause delays and cost, right? So implementing everything on cloud as a virtual implementation is called digital twin. So if you have a manufacturing, whatever the systems are involved there, you basically create a replica virtual system, and you build processes which are updating the same data in your centralized virtual implementation of supply chain. And then what you can do, you can run simulations that, okay, if weather is going to be bad for next 3 days, how it's going to impact, and you can run simulation across each and every pipeline and build a holistic solution. So that is what called digital twin. Twin means like it's a replica, right? And it's a digital only, so it's all virtual. So that is the concept, a paradigm which you will hear when you go in supply chain or Google Cloud side, right? Most of the companies talking about that, yeah, we are implementing digital twin. So digital twin implementation is a very cumbersome, very big process. So which companies can't do it like in short time frame. So what they do incremental implementations. So one of the implementation of what we are showing in today's call is the demand sensing implementation, right? So for that, like you bring in some subset of supply chain data to Google Cloud and build using AI and ML model the demand prediction pipelines. Go ahead, Shilda.
So, moving on to fewer benefits, like what supply chain data will be having when we are integrating into GCP. So, there can be fast upgrades, like by leveraging the automation tools and the templates, we can have faster upgrades because there are multiple tools and templates and flexible deployments available in the GCP, and this saves the time as well. Then Google owns secure network. So we all know that Google Fiber is the most secure network, and we can have good encryption as well on our data. Then on-demand growth. So we can have a flexibility to provide the services to the customers whenever they need them. So this is the flexibility which will help in our on-demand growth. Then we will be having reduced downtime. We will be having reduce time and cost also, because with BigQuery we can run as pay as you go on models, and we can have the consumption based pricing models as well. Then we have, last but not the least, empowering data driven insights. So whatever data analytics and AI services are happening, so it helps in enhanced decision making, and we can empower our data driven we can empower our data also, data driven insights also. Moving forward, I would like to uh, talk about a bit about SAP ERP solution. So it is one of the solution which is generating our supply chain currently, and we have fewer modules like sales and distribution, material management, production planning. So these are the fewer modules which will cover our supply chain cycle. And talking about the sales and distribution module, it manages our sales, delivery, and billing. Material management handles our procurement and the inventory. Financial accounting and controlling handles our payables, receivable from customers and vendors. So this is a basic idea of our SAP ERP system currently, which is there. And there are few tables also, tables and master tables also linked with these modules. I am trying to show these tables because it will be seen in our demo, and uh, we can have a bit of understanding over here that what is the header data and what is item data. So, let's take an example of a sales document. So, sales document have a header data and item data. So, VBAK is a table currency, and it consists of a sales document number, date created, time of creation, name of the person, etc. And the VBAP table, item table, consists of the material number of the material, then the document item number, and the material data for the sales document. Similarly, we have header and item data for every other modules, like purchasing, billing, delivery, etc. And then we have master tables as well. The master data never changes, and there can be three types of master data: customer data, product data, and the finance data. So these are few of the master tables which will hold the master data for a material, and it will be same throughout the cycle.
So yeah, so one thing I wanted to add here is, as a GCP solution consultant, whenever we go to different clients' place to implement supply chain analytics, very large number of customers, they use SAP systems. So there are different type of systems. Shalja can elaborate more on that. But like SAP ERP implementation, like HANA is one online one. I think Shalja, there is a E4, right? What is it called?
ECC, S4 HANA.
Yeah, yeah. So
ECC
there
is
are,
the
ECC is the main ERP, is it?
yeah. It's now we have S4 HANA as well. We have SAP on cloud as well. So uh,
Okay.
it has
So,
evolved.
so we always interact with customers holding their data in SAP ERPs, and the first thing in the like moving this data to cloud always it starts with understanding what tables we are going to bring to the cloud in the warehouse, BigQuery warehouse. So understanding these modules, which are again like divided into different domains, which Shelja explained, and then understanding the tables so that we are clear about the data. So if when tomorrow when we are building dashboards about supply chain side and building machine learning model, we will understand where are different data elements and how we can leverage to build demand predictions or any other inventory management models, so we can build some of those pipelines. So understanding the data set is very, very important. Okay, go ahead.
So now we will try to understand how we can get this data, this supply chain data from SAP ERP to our Google Cloud. So here we can see flow wherein we are looking at the SAP LT application server, BigQuery connector, then the BigQuery tables and the streaming API. Let me talk about this a bit. So what is a BigQuery? It is a fully managed, serverless, and cost-effective data warehouse that will help to manage and analyze the data with the inbuilt features like machine learning and business intelligence. So this is BigQuery, BigQuery is about, and the BigQuery connector. What is that? So it is a simple and cost-effective way to make SAP data fully accessible with BigQuery by leveraging their existing SAP LT replication server. So if we have SAP LT replication server, we can download and implement an ABAP enhancement here. So there is an enhancement in SAP. So that ABAP enhancement technique we can use to stream the data directly into the BigQuery. So currently this SAP LT replication server uh, is already there, which is connecting the other source system like S4HANA or ECC system, and it can capture any changes coming through an RFC connection. So here, from our RFC is nothing but a function module which we call, and which we wherein we give the port and the connection details, and we connect the data source through it and get the required data. And currently, this SAP LT replication server is being already used at our SAP end to get the data from any SAP source. So the same we will be using, and through BigQuery connector for SAP. So the target of the replication in SLT here. So this is the source, and our target of the replication in SAP uh, is a body. So there is a body also, business add-ins in SAP. So we will be enabling that for the code to go into the external targets. This is where the Google Cloud Code for the connector here receives the records from the source. Okay, so and it sends them to the BigQuery. How it sends them to the BigQuery? By a streaming API. And a BigQuery connector authenticates here if a record is already exists or not. If it isn't existing, it also creates a new one. Apart from creating a record, it can handle the data type conversion, error handlings, and the table partitioning as well. So
So
this is
just
the
to,
basic. Yeah.
yes, just to add one more thing, like the SAP LT replication server is implemented by SAP, including the connector, and it can be deployed on GCP or SAP cloud side, right?
Yes.
And one thing like the data schema implementation in BigQuery, the connector automatically creates tables if they are not present. Is that correct?
Yes.
Okay,
So through business add-ins, it is happening.
got
So
it. Okay.
there is a platform business add-ins through that we can create these tables.
Sounds good. Rajiv, like we will take the questions at the end. So
Sure.
we'll
Okay.
cover the demo and then we'll go through the questions.
All right.
Okay. All right.
Okay.
So connector, I think the connector is typically just like Google has a lot of other connectors to various source systems. This is also one more important, the majorly used connectors, which we generally implement at customers' places and bringing data to BigQuery. And this connector, I think Shalja will explain how it brings not only the historical data, but also the regular change data
Mhm.
periodically to BigQuery. Yeah, please go ahead.
Yeah. And here we have given a link for further details if you like to refer. Moving on, Cortex. So what is a Cortex, and what are the underlying features in this Cortex framework? I'm going to talk about that now. So this is how our Google Cloud Cortex framework looks like, and this is a new approach to make it easy for us to innovate in the cloud with the SAP data which we are bringing. And this Cortex framework helps us with the new architectures. They can be scenario driven and accelerators and the integration services, which we will talk about now. And we can gain new insights as well, which will reduce the time uh, with all the accelerator contents and the templates for the SAP data, which is getting into the BigQuery.
So
Then,
I'll add one
yeah.
line here, Shalja, just to give everyone very like clear clarity around this thing. So think about this. Like, let's say take an example of building a dashboard on supply chain side. Like, what is my inventory look like on a weekly basis? So to do that, we have a source level SAP data. you will have those raw tables, let's say, copied periodically by the BigQuery connector to BigQuery side, right? But you would need to build some sort of a dashboard centric table in BigQuery, so which can drive some of these dashboards. So now these data models in BigQuery, you will provision those for some of the machine learning model which you are trying to create. You will create some sort of a table structure for your enterprise. So given that the Google Cloud has worked with many customers, they have identified patterns and they have identified different data tables or models, you call it, for BigQuery, which then can be pre-provisioned, and all you have to do is map your sources to those tables. And then once the tables are there, you Google has also created like sort of dashboards which you can leverage, pre-built dashboards, so you don't need to do too much work. And exactly, the machine learning models and also Shelja will explain more. But they have built some of these key artifacts, and I know the data people in this call will understand how much an effort it is to build these consistent data blueprints or models which covers the whole enterprise needs. And definitely these models which Cortex create, you can further customize it, but it gives you a very big head start to build the core features on the supply chain analytics side.
Yes. So, talking about the three components, so let's talk about the Cortex Data Foundation. So, through this, we will be having predefined data models for the BigQuery herein for the SAP ERP data modeling. And through that, we don't have to use joins to combine the data on the header and the item level. So, all we will be having the templates therein, and we don't have to do extra work of putting the query there. And it also provides the processing scripts to automate the things like our change data capturing process, our sample machine learning templates, and we can get started with the Google visualizations as well uh, for our AI and ML capability. So these, as it says that we will be having data staging and processing templates also. We will be having raw data. We will talk about this in the later slide. So this is about the data foundation. Then we have AIL model example. So Cortex extend the value of our Cortex data foundation, which is here, and it gives us the AI and ML model templates as well to directly start on visualizing our content of the SAP. Then
So just
we will be
just a
having, yeah,
just a correction, actually, when you are saying visualizing, so data foundations are just the data models, but these
yeah,
AI ML model templates, they are basically Vertex AI pipelines and model code which Google is giving us, so that we can build demand sensing, demand prediction, those kind of models very, very fast, right? Visualization is provided through Looker only, Looker dashboards, not through AI ML model templates, correct?
yeah.
Okay.
AI/ML models will be the definitive models which we will be having, and we don't have to uh, specifically create in our Google, because there we have the methods of creating a different Vertex AI pipeline and different Vertex AI model manually. But here, Cortex is providing us those models in the framework only.
Okay.
Then we have an application layer. So there is this Cortex application layer. They are providing the microservices templates to so that we can securely consume and we can share those results in the downstream systems. Like we can allow our external applications to consume results through our scalable APIs, and there are PubSub messages also through which we can connect the external systems and consume whatever is happening here and give the information to them.
Yeah, so I think just
So
just one point there. Uh, so, for an example, if you have a pipeline where inventory is going or reaching a threshold level, then some of these application layer templates which are created, which will track these levels, they will push these inventory level details to a PubSub topic, and now your applications can subscribe to those PubSub topic and perform more actions. So the Cortex framework is providing not only artifacts for your supply chain analytics, but also applications driving some actions on whatever is getting generated or captured. Go
So
ahead.
this is a brief introduction about our Google Cortex framework, and we will go in detail in our demo section. Then let's talk about with whatever dashboards and templates we were talking about. So we will be having few dashboards like the finance side dashboards here: accounts receivable, overdue receivables, total receivables, and doubtful receivables. So these are the dashboards Google already is providing us, and we just have to plug in the data, and we can uh, we can visualize our results through these dashboards. And this is about the finance side, and this is about of the order to cash side. So sales performance, we can see order fulfillment, billing pricing, and the order details. So we don't have to manually
These are
make
all these are all Looker dashboard, and a company
yeah.
can basically enable Looker and leverage these dashboards out of the box, so that they have all these reporting solution in place for their sales and financial aspects.
Yes.
Okay.
So let's understand the data foundation currently, which is happening for our Google Cortex framework. So Cortex framework is designed in such a way, and it can work well with any tool that can replicate the raw data from the SAP tables, and through leveraging the SAP SLT system and the BigQuery connector, we can integrate real-time data streams from the SAP system. So here we are seeing the SAP source on-premise auto compute, and we are having a source project and a target project. So what is the source project? So project where the source data is located, and the data which is coming from the SAP, and through so from the data models, like from the source project, the data models will be consumed, and this project is normally accessed, this particular section is normally accessed by the technical people, and there is a target project. So this can be accessed by our end time users, and to get the visualizations, to see the ML models accuracy or other things. So this is the
So
difference between source and target.
quick point there. Companies can put both in single project or segregate.
Yeah.
A lot of times, I think data people understand that reporting is generally kept in a separate system so that it is not impacted by your daily ETL processes, and that's why the segregation is shown here. So if you want to implement raw pipelines, ETL pipelines, producing raw data, and also processing the change data, capture data, and creating the data sets, which then which is then populated in the target reporting side of tables. This is how it is maintained in the Google Cortex framework, and that basically is a standard production practice in company.
Yeah. So talking about our raw lending data set, so it will consider all the new records and the changes which is coming from our SAP side, and basically with BigQuery, an ELT approach is preferred, which means instead of merging the record, a new record will be inserted, and then then merge the record afterwards. Then the Google Cloud Composer can schedule the operations, and we can deploy the automated scripts to process the changes as a part of a Cortex data foundation. This will go into the CDC process, where CDC stands for a change data capture. So it will see if a new record is coming, if an update is coming with a record timestamp, or uh, if a record is coming with the with the delete mm, information in it. So of all these processing, Google Cloud Composer will do, and bring the data in the CDC process. So this Cloud Composer uh, is happening in the activities behind this Cloud Composer is already happening in this framework, and it will be converting our raw data into the change data. Okay.
So other
And
than data model, I think one point I will
yeah.
add, other than data models, Google is also providing a DAG, Python DAG, which runs in the Cloud Composer and runs this data pipeline, the ETL process.
Then finally, we have this layer that has the business logic and all the models that will be consumed by the end users. So, as Vijay said, some customers want only this data sets available to the end users and separate the technical data sets. So that's why we are having source and target project as a different projects. Otherwise, we can have a same project as well. So yeah, so this is about data foundation for like a brief intro about a data foundation for our Google Cortex framework. So, apart from having the dashboards and the templates, we have this particular method as well for us from provided by Google Cloud. So, Cortex provides us more advanced solutions such as demand sensing, which combines the data like the Google Trends, the weather conditions, and etc. And it will leverage those that framework, and it will give us the demand sensing and demand forecasting details, and through that we can plan better. So what is the demand sensing? And since it is the most recent approach that leverages the advanced analytics, AI and ML techniques, it can predict the customer demand with higher accuracy and agility through these techniques. And demand forecasting, on the other hand, is the more traditional method, which relies on the historical data to predict a future demand. And demand sensing not only predict the predict leverages the advanced analytics and AI, but it also considers the various sources like our weather, Google Trends, and the weather information also. So an accurate plan is really essential for reducing the business cost and maximizing the profit. And Google Cloud Cortex Demand Sensing provides the predefined solution, which leverages the Google Cloud services like we have BigQuery, Vertex AI, and Looker together with the SAP ERP data which we have taken from the
So
SAP.
just to summarize, Shalja, I think demand sensing is a more modern way of forecasting the demand, and Google Cortex framework is providing Vertex AI pipeline templates and the model code to do the demand sensing on the data model data foundation, which already provides. So if a company wants to implement demand sensing, modern demand sensing, they can leverage Google Trends, which is already there in the Google account, bringing the data, weather data, all, and utilize all these templates. And using this accelerator, they can quickly put together the demand sensing solution and start predicting demand. So maybe we can jump into the demo and show what Google Cortex, how to set up this thing very quickly, show the GitHub repository, and
Okay.
we run this, what tables are created, what Vertex AI pipelines are created, models and all. So we
Yeah.
can dig deeper into those things.
So quickly, I'll go to this. So everything we know about the deployment of the Cortex is documented in this open source GitHub repository. Anybody can access and see what is happening there. So here after so here, so we have this Git clone, and after a Git clone, we will be adding recurse submodule Slack, and we will be getting all the available content from the Google Cloud Cortex Foundation here from the GitHub. Okay.
One very quick question, if you can go up a little bit, just to show. So this is the core Cortex Git repo, which
Yeah.
includes all these source modules, and you will see the deployment pipeline files and all. So when you clone this on one of your Google EC compute engine machine or using Cloud Shell, you can clone it and then run some of these command lines to set up the whole Cortex framework and set up the whole Vertex pipelines very, very fast.
Yeah. So moving on, this is the command which will be getting our source project. which we talked about, the target project, our change data processing. So let me just show you how the look and feel of these things after doing this. After doing this step, and there are few other steps which I'll be discussing. But before that, I just wanted to show you how this BigQuery and the project will look like. So this is my screen of Google Cloud, and this is I am in the BigQuery. Okay, so when I go here, I will come here. So this Cortex P1 is the project which I created. So in our case, since we are using the repository data and it is a test data, not coming from the SAP system in real time. So the Cortex is already providing us a test data to have a hands-on as well. So we will be having only one project, Cortex P1, and this is how our data set will be getting created after all the steps, and
So
we will.
just to add one thing here, so the Cortex framework has two options. One is like either you are bringing data from your SAP systems using BigQuery connector, or you can leverage test data. So for this demo, we just leverage test data. Uh, and once you run that command, it will create all these BigQuery tables and fill in that test data in those tables. So this is our data foundation tables. So if you look at maybe Shalja, you can show raw landing, what kind of tables
Yeah.
are getting created. Let's show the raw landing and then we'll come to CDC.
So in our case, raw landing we will not be having because
Okay.
we are not getting data from
Oh,
SAP
so the
system.
CDC process is
So
the test data.
yeah,
So it will
CDC
show it.
process will be having the data. So these are all the SAP tables. Like ADR6 holds the address data, B6 holds the accounting data, and then uh, EKKO and EKPO are purchasing data. Let me open one of the table over here and just.
Correct. Right. So while you're opening, I would like to add one thing. So why it is important to understand the SAP modules and their table naming conventions, so that you can easily map it out. Because when you look at these EKPO and all, it's very hard to understand the mappings. So knowing the SAP side of modules and table structure, you can then come and correlate what kind of data is present in these type of tables, and then you can build your dashboards, models, and all.
Yeah. So as I have already worked in it, so I know this is a purchase document number, this is the item number of the product, and so on. So this is my item table, this is my header table, which will only contain the header data, and we have customer data as well. So these are few tables coming from this is my delivery data. So these are few tables which will be getting populated automatically. So if currently we don't have raw landing, so if we would be having that, so we will be having two tables here. But we here the Cortex is bringing the data in the CDC underscore process. So
Sure.
let
So
us go back. Yeah.
one quick thought. So after CDC process, like you also have the reporting data sets, right?
Yeah. So here this is SAP reporting.
So this SAP reporting, the names of the tables change there, correct?
Yeah. So
So that
accounting.
CDC, yeah. So CDC is, I think, 1:1 mapping source tables. But when you come to SAP reporting, which is more a business side or tooling side or ML side of tables, there the naming conventions change, and this is primarily the blueprint created by Cortex framework for easier understanding. And the pipelines, ETL pipelines provided by Cortex framework map from the source table or CDC tables to these reporting tables seamlessly.
Yeah, so these are like we can understand it more. Like end user can easily understand the namings here
Correct.
rather
So
than from the
because
CDC
these
table.
tables are non-SAP centric now, and these are more generic supply chain tables for reporting and utilization perspective. So even if you are not using SAP ERP, you are using some other systems for supply chain data, you can move the data through ETL pipelines to these tables, and you can still leverage the models and dashboards provided by Google. So that's the beauty of this framework.
Yes. So this is how we will be like getting the data automatically, and this command will provide us like will generate all the like all the tables which I have shown, raw data, then our models, then these there are few buckets for the log also, and so if we want to deploy that will be true. uh, these they have shown for Salesforce data also, which we don't need here. We are considering SAP data only. There are few prerequisites which is also needed. Let me show you. So to da- get the Google services, we have to run this command as well to get the Google Cloud services, and through this we can enable all the services like BigQuery, Cloud Build, storage, etc. And why we will need that? Because before before creating these tables and the data foundation, we will require two things in prior. Like we will need a storage bucket for the deployment process, so that the bucket can have all the DAG scripts which Vijay talked about, all the scripts which got generated, which generates actually are these tables through the Google Cloud Composer in the Cortex framework. And one thing is we have to make a Google storage, and second thing is we have to give the permissions as well. So permissions for BigQuery data using the BigQuery data editor and the BigQuery job users. Let me just quickly go through one of the. So here we can give the permissions. So all these steps also is there in one command here. So by running this on the Cloud Shell, okay, I forgot to mention the Cloud Shell activation. So where these command will run. So here we will activate the Cloud Shell. We'll click on this, and it will open us the place wherein we can put these commands and generate step by step. So here my project is mentioned, and we can put in our commands which I'm showing here. So
So one quick thing, because we have 17 more minutes.
mhm,
Um, you have shown the BigQuery tables, data foundations, how the GitHub repo, which provides all the instructions to run CLI commands to set this up.
yeah,
Uh, can we can we jump into the AI pipelines, Vertex AI
okay,
pipelines, and see the
okay.
code, the models, and all those things?
Okay, so this is about the Git Hub repository, and I overall covered many things and the prerequisite as well. Apart from that, Google Cortex has also provided us the solution of uh, leveraging the data, the commands, and other services to generate a Google Cortex demand sensing uh, deployment. Let's see. Quickly correct from the GitHub, this particular step we will only be getting. Let me go to BigQuery quickly.
So the first GitHub, what you showed, like it's going to set up the data foundation only, right? And for
Yeah,
demand sensing, you have to go to some other place and run the again same instruction sets.
yes, so we have this instruction set, and so we can deploy demand sensing. So up till now we will be only be adding getting the data models data set. We will not be having Vertex AI data set up till now, and we will not be having the forecasting models as well. If we see here demand sensing evaluation, and in here in CDC process also there are few tables for demand focus, and it will not come until and unless we will run the steps over here. So Google Cortex has provided us the demand sensing solution, and through that we can leverage all these things. So after putting this command, we can have all the information which was earlier also we were having, but extra will be a Vertex BigQuery data set. So generally, Vertex AI is a artificial platform which Google is providing, and we can have multiple ML models in one roof with through this Vertex AI platform. And we will be having data foundation, the Vertex AI. So these steps should be manually done if we are not leveraging this deployment solution. So to this one liner, one deployment solution, we will be having all these in one go, and this framework will give us all these in one go. There are some prerequisites on which they are doing the calculations for our demand forecasting. Like they are taking the predictions up to 3 weeks, and they are having a context window of 52 weeks. They are uh, looking back in the model up to 52 weeks for training the model, and there are model training budget hours also, like only for 1 hour or so our Vertex AI Auto ML will run.
So one quick
Yeah.
question. Can we jump to directly to AI, Vertex AI pipeline, show those things, what pipeline got created, and then show the Python model code in the repository, which
So
the then team
yeah,
can modify, and what model it is using, what algorithms it's using? Can we look into those?
yeah. So going to Vertex AI pipeline, let me see if I have it. Okay. Yeah. So after doing the steps which was written there, we will be having Vertex AI pipeline already. Yeah, Vertex AI. So if I was doing manually, it would have taken a lot of time for me. But since we ran that command, it will create a Vertex AI here. This I created manually, and this got created automatically with the topic demand, Cortex demand sensing, and this is how it is shown here. And talking about the code, talking about the code of the repository. So it is all in our source code here. So like submit pipeline. So we have AI platform, and it is getting all the data, like whatever I talked about, forecast horizon wave context window. So all these code, like creating a forecasting pipeline as well, getting the model, then evaluating the model here in itself. I don't have to evaluate the model separately. So it's preparing the data, processing the data, then it's creating the Vertex AI data set also, which we have seen with the fields like demand or automated demand sensing, tables, etc. Then forecasting model training, it's happening.
So
So
this is using auto ML, right?
yes.
So one of the good part of auto ML is like you don't need to worry about hyperparameter tuning and all. So Google Cortex is already providing this nicely written model for demand sensing. And if you need to customize, we can definitely customize it and run it in the same pipeline. But the pipeline is created, which can run, scheduled, and you can get your predictions on a regular basis. And that predicted data is also, I think, stored in BigQuery tables, correct?
Yes. So if we go again to our BigQuery data set. So this created this Vertex AI data and the demand sensing evaluation. This is the latest one with the timestamp. And whenever the CDC data processed is like the data coming from SAP is there, the change data will also be there. Then we have to rerun the command to get the latest possible data in this demand sensing evaluation data. So this is how we will be having all the details. Like if we go to this, so as we talked about that, it will consider the weather trends also. So we will be having temperature, customer ID, the location also, region also we are having. Then the predicted on week start, predicted value, and the week the evaluation happened on 13 weeks. Then yeah, so this is automatically created, and we can attach this data to our Looker dashboards, which we talked about, like order to cash and finances, and we can see what is happening, like what can be our demand prediction, what can be our like orders receivable, finances, etc. So this is very time saving, uh, and we don't have to manually do it. Another thing which I manually created, uh, I created Vertex AI pipeline from the scratch, and I created a notebook in that. I tried to take this data. So, I took this BigQuery data in SAP reporting over here. I took the vendor data, which was having the maximum fields which I wanted to have in my forecasting model, and I created a price prediction model using that SAP data. So I just want to quickly show over here. So there are also few steps to access the bucket and access the data in the uh, BigQuery data set. And I took the reporting data of vendor performance. I took few fields. I took many fields first, but later on, when my model is not giving me proper results, so I had to eliminate, and I had to keep only important ones after seeing my feature importance graph. And this is how let me quickly go to. So this is my material types, showing which purchase organization was mostly being used, and then what were the material types, like FERT was the major one. Then these were the feature correlating with the prices of a product, and we had the major dependency from plant, company, purchase organization, and the yeah, these three fields were the major ones which were affecting the price. And then yeah, then I prepared the model. So I built a linear regression model. Then I did the random forest. Before that, I did the decision tree as well. So I found that random forest is giving me a good score, although it is still less. But since this is a test data and it can have outliers and other discrepancies as well, so uh, this is how I made it manually, and
So yeah, I
also
think
deployed the Vertex.
just to,
Yeah.
just to add here, we have only 5 minutes remaining. So you showed, just to summarize, you showed Cortex framework. So the core part of this today's meeting was understanding the supply chains, what is supply chain data, how we can bring supply chain data to Google Cloud. But it's not just about bringing supply chain data to Google Cloud, but also leveraging a very good framework, Cortex framework, which gives you like pre-built artifacts, which is a data model. How by running this git repo commands, you can set some of these things very, very fast and enable the companies with AI, Vertex AI pipelines and the Looker dashboards. And you showed that how auto-generated Vertex AI pipeline using AutoML predicting and doing demand sensing. But if someone wants to manually create their own forecasting pipeline, like you showed with the random forest and all, you can quickly build it up. So, so this is a good summary. A lot of companies are right now planning to move supply chain data and use more and more AI and ML for the prediction perspective or classification perspective. And we see we are interacting with a lot more companies. So let's wrap it up here, and we can take few questions in next 5 minutes. Rajiv, you had some question right earlier.
Hi, can you hear me?
Yeah, we can.
Yes.
Okay, perfect. Yes, yes. So thanks. I think that summary was good because I felt we covered a lot of ground, and for me to appreciate what we are doing, especially that concept of having it, digital twin was something new. I wanted to understand more. Is it more of a strategic thing, or is it a tactical problems for something like an actual event happening, and you try to solve some kind of an actual business problem? So I think you kind of
Yeah,
answered
so
that.
you can
Go
correlate.
ahead.
Yeah, so you can correlate the digital twin with a typical organization building data lakes, data warehouses, and all, and trying to get a wider enterprise level and analytics, right? So you can just correlate digital twin in the same way that you are building a centralized data platform, collecting data from all of your supply chain areas, building a virtual pipeline. So there are two pieces of a virtual pipeline, right? So let's say I order cotton from a supplier, and my manufacturer, which is going to build clothes, is dependent on that cotton. So I'm capturing all of these my cotton orders in my tables. When the cotton order gets delivered, my manufacturing will kickstart through some planning process and all. How can we put all of these together as an operational process virtually by building some services, microservices pipelines, and building analytics so that you can run simulation that if an order gets delayed, then my manufacturing starts now, and then delivery delays. So all of these things you can virtually create and perform simulations. So that is called digital twin. That instead of having these things physical run, you are copying 1:1 as a virtual copy, and which includes not only your data, what you're collecting, but also applications, which is driving some of these processes virtually. So this is like, that is a very big undertaking. Digital twin is like a very big undertaking. Same as a company building a complete enterprise warehouse solutions end to end, which takes time.
So that kind of opens a bunch of questions. But before that, I would say that showing cognitive was a good exercise. I've seen some demos, but this was something close to what a real world would look like. uh,
Correct.
so in a real practical world where you have an existing solution, so do these things come up as a replacement of an existing SAP module, or is it something a homegrown system we are looking to replace, or we are just adding new capabilities to the enterprise?
Yeah, so same thing, like I'm drawing parallels here so that I can explain clearly. So same thing, there are a lot of tooling available in the market. Even SAP does provide analytics on their cloud, the solutions and all. But why do companies come and build things on cloud solutions? Is primarily to open up their data to various tooling and the scale, right? That is the main benefit why AI and ML, which is the bread and butter of Google. A lot of companies jump to Google Cloud mostly for AI ML side because that is far more advanced compared to other cloud solutions providers. So bringing in SAP data to cloud then helps and opens up new capabilities. So that is the main reason why we are doing it on GCP.
Good point. Okay, good to know. So yeah, so that was my general area of questioning, like what is the motivation to undertake these kind of initiative. Yeah, I can see like a capability, but it could be done in a multiple ways, or if it has not been done, then it could be a greenfield project.
Correct.
Yeah. All right. Thank you.
Yeah. Who else? Zulfi?
Yeah, I just want a quick question here. So if I understand correctly, we are actually plugging in the Google Cloud to the on the existing SAP data and just using it for the analytics purposes for forecasting and other analytics.
Correct.
But is it continuously trained based on the existing data gets being updated into the SAP database, or is it gonna be like one time, and
It's not.
then it will?
Currently, the AutoML model, what is provided by Cortex, is trained one time with the historical data. So you can bring in large amount of historical data, train the model, and leverage it for demand sensing or forecasting. But now with this new transformer-centric models, you can just do transfer learning and keep training as the new data is coming in. So you can plug in that also. But out of the box, it's a one-time trained model which you can leverage.
Okay, got it.
Any other questions? If not, thanks a lot, everyone. Thanks a lot, Shalja, for presenting.
Thanks, everyone.
Okay, we can record.
Thank you.
Stop the record. We will share the recording and slide with everyone.
All right. Thank you.
Thank you, guys.
Bye.
Bye.